The Kepler telescope is one of the most significant scientific instruments ever launched into space. Launched by NASA in 2009, the Kepler telescope was designed to search for exoplanets, planets orbiting stars outside of our solar system. By detecting the slight dimming of a star's light as a planet passes in front of it, the Kepler telescope has been able to detect thousands of exoplanets, including some that may be habitable. But the Kepler telescope's capabilities go beyond just exoplanet detection. The massive amounts of data collected by the telescope have allowed scientists to study a wide range of astronomical phenomena, from variable stars to supernovae. And in recent years, the Kepler telescope has been used to search for evidence of advanced civilizations in the universe. One of the most intriguing objects that the Kepler telescope has been used to search for is the Dyson sphere, a hypothetical megastructure that completely surrounds a star and harnesses its energy output for a civilization's use. While no definitive evidence of a Dyson sphere has been found yet, the search continues, and the data collected by the Kepler telescope may hold the key to finding one. The Kepler telescope has revolutionized our understanding of the universe, and its legacy will continue to shape astronomical research for years to come. The universe is a vast and mysterious place, filled with wonders beyond our imagination. One of the most intriguing possibilities that scientists have considered is the existence of Dyson spheres. A Dyson sphere is a hypothetical megastructure that completely surrounds a star and harnesses its energy output for a civilization's use. The idea was first proposed by physicist Freeman Dyson in 1960, and has captured the imagination of scientists and science fiction writers ever since. If a civilization were to build a Dyson sphere, it would require a staggering amount of resources and engineering expertise. The construction process itself would be a massive undertaking, involving the gathering of materials from asteroids and planets, as well as the construction of enormous structures capable of withstanding the intense radiation and temperature extremes near a star. But if such a structure were to exist, it could provide virtually unlimited energy for a civilization, and perhaps even serve as a way of signaling their existence to other civilizations in the galaxy. The search for Dyson spheres and other extraterrestrial megastructures is a topic of great interest to researchers in the field of astrobiology and SETI, the search for extraterrestrial intelligence. These megastructures are massive, hypothetical constructions that an advanced civilization could build to harness the energy of a star or even an entire galaxy. Scientists are using a variety of techniques to search for these structures, including analyzing data from telescopes, looking for unusual patterns of light, and even searching for evidence of massive engineering projects in space. The Kepler Space Telescope has been a game-changer in the field of exoplanet research, discovering thousands of planets outside our solar system. One method involves analyzing the light curves of stars observed by Kepler for unusual patterns of dimming or brightening that could be caused by a Dyson sphere passing in front of the star. The data analysis process is complex and requires careful consideration of possible natural explanations for the observed phenomena. Humans have been searching for signs of extraterrestrial life for decades, but the question of whether or not we should attempt to communicate with any potential intelligent beings remains a controversial and complex issue. The possibility of interstellar communication raises important ethical questions about the potential risks and benefits of sending messages into the cosmos. Proponents argue that interstellar communication could lead to new scientific discoveries and the potential for establishing contact with other intelligent beings. But opponents argue that we should be cautious, as we cannot predict how a potential extraterrestrial civilization would react to our messages. Critics suggest that sending messages into the cosmos could attract unwanted attention or even put our planet at risk if a hostile alien civilization were to detect our signals. The international scientific community is actively discussing the ethical considerations of interstellar communication, with some advocating for a cautious approach and others calling for a more proactive stance. The concept of a Dyson sphere, a hypothetical megastructure that surrounds a star and harnesses its energy output, has captured the imaginations of scientists and science fiction enthusiasts alike. But what if there are other ways to harvest energy from stars beyond a Dyson sphere? Scientists have proposed several alternative theories for energy harvesting from stars that could potentially be more feasible than building a Dyson sphere. One such theory involves the use of a stellar engine, which would utilize the rotation of a star to generate energy. Another idea is the gravitational lensing method, which would use the gravitational lensing effect of a star to focus its energy output onto a receiver. Other concepts include using a star's magnetic field to extract energy, or even extracting energy from a star's radiation output. While these concepts are still in the realm of theory, they offer new and exciting possibilities for energy harvesting from stars. The exploration of alternative theories for energy harvesting from stars is part of a broader effort to find more sustainable and efficient ways of meeting our energy needs as a species. From wind farms to solar panels, humanity has made great strides in renewable energy, and the search for new methods of harvesting energy from stars is just one piece of this puzzle. Dyson sphere would have far-reaching implications for astrobiology as well. Some scientists argue that the energy output from a Dyson sphere would be detectable by our telescopes, while others believe that the structure would be too well camouflaged to be detected. With this new understanding, NASA and other space agencies have launched new missions to explore these distant worlds. TESS, which is sometimes called the successor to the Kepler telescope, is designed to search for exoplanets around nearby stars. Its powerful cameras can observe thousands of stars simultaneously, scanning the sky for transits, or dips in a star's brightness caused by a planet passing in front of it. TESS builds on the legacy of the Kepler telescope by providing us with a whole new set of targets to study. It's like a treasure map, leading us to the most promising exoplanets for future study. The James Webb Space Telescope, the successor to the Hubble Space Telescope, is also expected to be a game-changer for exoplanet research. With its advanced infrared capabilities, the telescope will be able to study the atmospheres of exoplanets in unprecedented detail, potentially detecting signs of life. The Kepler telescope gave us the motivation and inspiration to explore these distant worlds, and now we have the technology to take that exploration to the next level. We're excited to see what we'll discover with the James Webb Space Telescope. The legacy of the Kepler telescope will continue to influence and inspire future space missions for years to come. Who knows what we'll discover next in our ongoing search for life beyond our solar system. In conclusion, the Kepler telescope has left an indelible mark on our understanding of the universe and has paved the way for future space missions that will continue to push the boundaries of our knowledge and inspire us to explore the wonders of the cosmos.